Welcome back, focused learners. Today, we're taking a massive leap. We are moving way beyond simple AI chatbots into something far more powerful and honestly, a lot more practical. In this explainer, we're going to trace the evolution of a long-running, fully functional, and highly secure AI email triage agent known as NemoFlow. We're talking about an autonomous assistant that doesn't just draft a quick reply for you, but actually manages your workflow, remembers your past interactions, and most importantly, operates within strict, enterprise-grade security guardrails. So if you've ever felt completely overwhelmed by your inbox, or you're just curious about how real autonomous AI is safely deployed in the wild, well, you are definitely in the right place.
Okay, let's dive right into the structural blueprint. First, we'll look at the email overload problem. Then, building the triage agent, followed by persistent AI memory. Next, the trust trilemma. And finally, securing with NemoClaw.
All right, starting off with Section 1. The email overload problem, or as I like to call it, communication chaos.
Look at this stat from Microsoft's 2023 Work Trend Index. The average Microsoft 365 user spends 57% of their app time just communicating. Over half your day gone. Poof, just managing the back and forth. In fact, knowledge workers are losing more than 2 whole hours every single day to email triage, meeting prep, and scheduling follow-ups. That's a massive, measurable loss of productivity, right? And it perfectly validates why we absolutely need a bounded automated triage system.
So to fix this, our implementation, NemoFlow, actually connects to your inbox using the NVIDIA CLI. It explicitly filters that incoming chaos into 4 distinct buckets. It separates the drop everything emergencies, labeled urgent, from the ignore forever marketing noise, which it just tags as noise. For urgent and action items, it actually goes ahead and drafts replies, but it goes even further than that. It fetches your calendar events to generate structured meeting briefings, complete with talking points, and it even generates a prioritized daily action plan for you every single morning. It's a real game changer.
Moving on to Section 2, building the triage agent, using the NVIDIA CLI and an LLM brain.
Now, we obviously don't want to just hand an AI model direct, unrestricted access to our mailbox credentials. That's a recipe for disaster. Instead, we use a controlled architecture running on a super reliable 15-minute cycle. The agent runs continuously, and it actually executes 4 major autonomous cycles per day: a morning briefing, email triage, pre-meeting prep, and an end-of-day summary. And it does all this without any human input between cycles. Every 15 minutes, the Python orchestration script wakes up, fetches unread emails, classifies the snippets, drafts replies, and clears out the noise.
Now, what's really interesting about this is how the agent actually thinks through these steps. It uses something called the REACT pattern. That stands for reason, act, and observe. The LLM isn't just blindly firing off code. First, it reasons about what it needs to do. Then it acts by utilizing a specific tool in its layer, like the NVIDIA CLI. It observes the result of that action and feeds that right back into the next reasoning step. It just loops like this. Typically, each task runs through about 3 to 10 of these steps before completing. To power a complex React loop like that, you need an LLM trained specifically for tool calling. You can do this using NVIDIA NIM microservices, which give you an optimized OpenAI-compatible tool calling API. This is what lets you bind external tools directly to open models, like Llama 3.1, using frameworks like LangChain. And the best part? This entire agent runs on NVIDIA NIM. You don't need a massive local GPU sitting under your desk, meaning you can deploy this agent on literally any Python environment, even Google Colab.
Let's jump into Section 3. Persistent AI memory, stop forgetting context.
You know how a standard AI chatbot is completely stateless? It basically suffers from amnesia the second you close the window. But our advanced NemoFlow agent uses SQLite memory to persist all its actions, drafted emails and meeting briefings across sessions in a local database. Even better, it uses offline-first CRDT technology. That's conflict-free replicated data types. Basically, if you have multiple agents working, they can sync and share knowledge across different machines automatically, with zero need for a centralized server getting in the way.
I absolutely love this philosophy. Markdown files are the source of truth. So instead of hiding data in black box databases, SQLite memory uses version-controllable markdown files. It parses these intelligently and uses hybrid search. That means it combines standard full-text keyword search with advanced vector similarity search. So the agent can recall exact details from your past emails or briefings based on the actual meaning of your query, not just if you match the exact keywords.
Which brings us to Section 4, the trust trilemma. security versus autonomy.
So, what happens when an autonomous agent goes rogue? Think about it. A compromised, persistent agent with live credentials could leak sensitive data, send out highly inappropriate emails, or, worst case, rewrite its own tooling. Every third-party skill you let the agent install is basically an unreviewed binary with file system access, and every prompt injection attack is a potential major data leak. It's a scary thought.
So the crucial point here is what we call the trust trilemma. Historically in AI, you could only pick two of these three: safe, capable, or autonomous. If you want an agent to be highly capable and fully autonomous, you almost always have to sacrifice safety. Why? Well, because typically security guardrails just live inside the prompt layer of the LLM itself. If the agent gets compromised or just gets confused by a clever prompt injection, those internal guardrails can literally be overwritten by the agent itself.
And that leads us to the final piece, Section 5, Securing with NemoClaw, the NVIDIA security stack. This quote just perfectly captures the dynamic. OpenClaw is the engine, but NemoClaw is the steering wheel and brakes. OpenClaw is the foundational framework that lets the AI operate autonomously. It's the engine, giving you all that incredible power. But NemoClaw, along with its core component OpenShell, provides the critical infrastructure-level control. It essentially wraps your AI agent in a highly isolated, enterprise-grade security sandbox. Let's methodically walk through how this protection model actually works. Look at the file system and process layers. These are locked down the moment the sandbox is created. The agent physically cannot override them. Then on the network and inference layers, NemoClaw acts as a policy evaluation layer. Before any outbound action happens, it checks the rules. There are three main policies constantly running: external recipient detection, urgent language detection, and PII pattern detection. If it spots something off, it intercepts and blocks the request.
And this brilliantly illustrates how NemoClaw moves security from just hoping the AI behaves to actual structural guarantees. If an action gets flagged by that policy evaluation layer, it doesn't just auto-execute. Instead, it gets securely held for a human operator to review via a terminal user interface. You get all the productivity of an autonomous email triage agent running across standard AMD, Intel, or NVIDIA hardware without giving up an ounce of infrastructural control.
We have covered a lot of ground today. We journeyed from the daily 2-hour grind of email overload through the react patterns and persistent SQLite memory of an autonomous agent, all the way to the structural OS-level security guarantees of NemoClaw. The technology to build a highly capable, fully autonomous, and structurally safe AI teammate is literally here today. So I'll leave you with this final provocative thought to consider. Is your infrastructure actually ready to truly trust an autonomous agent? Thanks for joining me on this Explainer, Focused Learners. Keep exploring, and I will see you next time.